Hi, today presentation is about smart medicines and healthcare, Internet of Things used for health monitoring system. My name is Jashandeep and my student ID is 303800759 and my partner is Sukhtinder Kaur. It is about outline, introduction, system, architecture, critical technologies, vulnerabilities and threat investigation, possible attacks, countermeasures, conclusions, or start with introduction. With the passage of time, the healthcare system has made many improvements with the use of advanced technological equipment. New technologies such as Internet of Things and wearable devices are used in health monitoring system. Internet of Things can thought of as a system of interrelated computing devices, mechanical and digital devices, objects and people. These technologies enable real-time health monitoring. Functions and applications. Following are some of the functions that are performed by Internet of Things devices in healthcare: remote patient monitoring, glucose monitoring, heart rate monitoring, hand sanitizer monitoring, depression and mood monitoring, operating monitoring. Following are the some application of Internet of Things in healthcare. Helps the doctors to perform surgically tasks quickly and efficiently. When wearable devices such as fitness band and watches enable parents to monitor medical condition. Internet of Things sensors alert authorities and health professionals in case of any emergency. System architecture. We have COVID-19 patient, oxygen level, blood pressure, pulse rate sensor, temperature sensor. We have to check this person. We use different type of devices, like we analog to digital converter, power plus 5 volt DC, Raspberry Pi, Wi-Fi, cloud service. So that's why doctor assistant assisted them through these devices. Let's move on. Critical technologies. Temperature sensor. These enable hospital and patients to keep track of the body parts temperature level. Analog converter. These converters convert the information into analog signals. Digital sensors. Digital sensor convert analog signal to binary signals, which is turned are sent to converter to analyze AI-based real-time information. Cloud server. Cloud server is responsible for strong information that is being generated by digital sensors. Mobile devices. They are responsible for receiving a response that is generated by sensor in case of any medical emergency, such as if a patient heart pulse rate drop, then these devices receive an alert and inform the patient of the condition with suggestions. Furthermore, wearable devices, smart watches, smart glasses, and smart detectors are used for monitoring real-time health condition of a patient that are incorrected with patient body parts. These are responsible for producing a response and are responsible for analyzing real data time based on any changes in the body condition. Monitors. These are the devices in the architecture that enable medical professionals to keep track of the patient health condition using hybrid and SAS visualization tool that display critical information even if the patient is sitting at home. Microcontroller. These devices are required for the purpose of synergisms. These devices are responsible for converting analog to digital converter to get information in proper digital format that can be easily analyzed by health professionals. Vulnerabilities and threats. Privacy vulnerabilities. With Internet of Things, patients are monitored in the healthcare system and then the patient's information is stored in the Internet of Things medical devices. Attacks such as passive attacks, in which attackers can change or steal the information regarding the identity of the patient, as well as sensitive and conditional confidential information of the patient and healthcare systems. Moreover, attacks like man-in-the-middle attacks, which attackers can compromise the security and privacy of Internet of Things in networks by interfering with communication to change the way to patient parties communicate data silently. For example, the gathered health information can be transmitted to the distant server where hackers can alert and intercept the information of the patient in order to retain the privacy of the data. Furthermore, security vulnerabilities. Internet of Things uses open wireless communication system in healthcare where the system impacted due to eavesdropping. IoT devices are unable to identify and stop attack, and attackers can break the encryption to increase patient information without authorization. Consequently, attackers can use highly access of infected devices with malware and harmful software. Moreover, medical IoT devices are vulnerable to botnet attacks through which attackers can change the information of the medical such as timing, name, doses, which can lead to serious health issues or death of the patient. Moreover, application vulnerability. With the passage of the time, IoT-based health monitoring systems are getting advanced with the introduction to new application. Preventive measures in response to any vulnerability can introduce into systematic application. This can significantly impact health monitoring systems such as error and omissions may occur while executing any medical task. For example, when certain commands is executed in the console of any application by performing malicious attacks such as select and forwarding attack, it will render the system to perform the task efficiently, like the patient health conditions such as blood pressure level, ECG result may come negative and cause the harm of the patient's health. Attacks. First, router attack effectiveness. Route information is changed. Security requirements. Continue route monitoring is needed. Approach. Attacker changes the routing table information and drop the packet of the to own end. Select and forwarding attack. Data packets are dropped. Security requirements. Sensor detective is needed. Approach. Internet attackers drop the data at desired location by behaving as a destination end. Replay attack. Duplicate transmission and unauthorized access is taken by attackers. Security authorization needed to be secured properly. Attackers first analyze the system activity and then send message to the receiver after the completion of the transmitter message. Denial of service attack. Service of the system is disabled. Early intrusion detection is required. System service is used and denied by the distributed attacks. Fingerprint and timing based attack. Malicious activities is done by the attackers. Transmission control is required. Attackers analyzed all the data traffic with the help of the sensor, and after they attacked, fingerprint to each of the messages to specific transmitter. Sensor attack. Modification of the data, failure of node and replacement detection is required. Attackers first look the sensor which have low power and failure, then replace the sensor to enter into the network. Let's move on countermeasures. For the vulnerability of security, proper system monitoring included setting the intrusion attack. Detection must be informed regularly in order to avoid the loopholes in the system that may render the performance. Certain tools such as Nitico and Metasploits can be used in order to perform security analysis against the vulnerability that may have been introduced into the system. Apart from this, correct authorization need to taken ensure the proper access control for the devices used to monitor health of the patient. Countermeasures for the vulnerability of the privacy. Certain rules, regulations, standards, and policies must be followed, such as CI provided based network framework, basic framework. Similarly, other preventive measures include use of encrypted passwords and VPNs must be followed so that risk of patients and healthcare workers' privacy must be minimized. Countermeasures for the vulnerability of an application. Some of the things needs to used and managed properly, such as authentication mechanisms, embedded firewalls feature with encryption capabilities. Moreover, tamper detection capabilities must be controlled. In order to overcome the vulnerability, new security features need to be included in the system during the design phase of the system. Here is the conclusion. We explored the function, application, critical technologies of uh, Internet of Things based healthcare system. We investigate the three types of vulnerability. There are privacy, applications, and security for Internet of Things based healthcare system. We also explore some of the possible attacks due to these vulnerabilities in Internet of Things based health monitoring systems. We propose some of countermeasures in order to overcome the above monitored vulnerabilities. Here is some reference we used to make this presentation. Thank you for watching.